Assalamualaikum and hi everyone! Welcome to our video presentation and the title is Revise Universal Soil Loss Equation Erosion. And this is our group members. Firstly, introduction. Soil erosion is one of the most significant environmental problems which affect the natural environment not only through the land and water quality degradation, but also technical structure and human activities. The revised universal soil loss equation is an empirical erosion model which is recognized as a standard method to calculate the average probability of soil erosion on enable land. This model has been adapted and applied in many regions of the world and providing the results and methods as an international application and comparability which to estimate the long-term average risk of arable soil erosion. However, there are some models consist of erosion factors such as soil erodibility, K factor, rainfall erosivity, alpha factor, land cover and management, C factor, slope length, L factor, slope steepness, S factor, and conservation practice, P factor. The estimated relative loss of soil income per hectare per year is calculated by combining or multiplying all the factors based on GIS, grid, cell, or polygons. An accurate simulation of soil erosion, such delineation, must consider the climatic, geological, topographic, and land covers throughout the catchment. Next, the objective. Number 1, to implement revised universal soil loss equation model to study the soil erosion at UITM catchment. Number 2, to assess soil erosion at UITM by revised universal soil loss equation model using IRC-GIS. And number 3, to identify the estimate average annual soil erosion A value, especially by using the revised universal soil loss equation model.
For methodology, the data that used in this mini project was provided by Dr. Rodiano Rosli. The method used in this mini project is Rosli model. Before the Rosli model start, georeferencing was done to all the data. Straight line and cross line was drawn according to the point, then insert the coordinate at the cross point. Finally, update georeference to complete the georeferencing. To create polygon or polyline, shapefile was created in the catalog. Select polygon or polyline in the menu. Then use the coordinate system Tibalai 1948R SO broniometer. Then editor is used to trace the polygon or polyline. Finally, add field and insert the data into the attribute table. This is the equation for Rosli model. To calculate factor R, range shapefile is selected in the ArcMap. Then trace the polygon and insert the data mean rainfall in the attribute table. Convert polygon to raster using conversion tools. Open raster calculator and insert the formula below into the raster calculator. A new layer factor R was produced after evaluate. To calculate C and P, the step is similar as before. Only the data used is changed into land use. Add the data into the attribute table. For factor C, C equal to 0.5 for plant, then C equal to 1 for no plant. For factor P, P is assumed as 0.9. Then convert the polygon to raster using conversion tools. Then insert the formula factor C multiple factor P in the raster calculator. Then finally a new layer factor C and P is produced. To calculate factor LS, the step is similar as before also. Add the data height into the attribute table. Then convert polyline to raster using conversion tool and to produce a layer DEM. Then use 3D analyze tools and select the slope in the raster surface. Put DEM into the input raster. and percent rise in output measurement. Then a new layer of slope is produced. Then open raster calculator, insert DEM multiple slope and to produce a new layer factor LS. This is the equation for factor K. Land use shift file was used again in factor K. Add a column in attribute table named as organic matter. Then use editor to highlight the columns, insert the data according to the soil type. Repeat this step with N1, N2, and P. Convert polygon to raster using conversion tools. Repeat this step with N1, N2, P, and N. Then the layers was generated. Use the raster calculator, insert the formula below to produce a new layer of factor K. Finally, gather all the data in raster calculator, use the formula in this flowchart. After that, use spatial analysis to reclassify the class into 5, then to produce a new layer E value. Using the data in the attribute table to produce a pie chart in Microsoft Excel, and insert title, grid, scale bar, legend, and north indicator to do a complete map.
Next, we will presenting our result and discussion.
After conducting a raster model by using ArcGIS, figures show 66% of the areas at UITM experience very low average soil loss. 21% of the areas has moderate year average soil loss, and 11% of the areas has high year average soil loss, while only 2% of the areas experience very high average soil loss.
So one of the factors that can affect soil erosion is the mean rainfall. So the mean rainfall at UITM was 138.9 megajoule millimeter per hectare our year. So according to a study, storms with increasing rainfall intensity yielded the highest runoff, soil loss, and sediment concentration. So next is factor K. So factor K is soil arability, which represent both susceptibility of soil to erosion and rate runoff. So factor K at UITM was at the range of 34 until 44.7 ton hectare hour per hectare megajoule millimeter. So most of the soil loss occurred at Western due to high content of sand and fine sand. So sand that is located at Western was 76.75% and fine sand was 67.20%. Fine sandy soils that are located in medium soils have a high risk of wind erosion and they are not stable and they are prone to capping. Moreover, the organic matter at Western was the lowest among other areas, and the permeability of soil was only 8.323 exponential negative 7 centimeter per second. So this indicates that the infiltration rate of soils at Western are lower.
Another factor for the soil erosion is factor L. Factor L is defined as the distance from the source of runoff from the point where interaction of angle and the length of the slope affect the magnitude of soil erosions. Soil erosion occur are located in Western and the slope length factor was 250 meter, which is higher compared to the other. The longer of the slope, the higher the risk for the erosion to occur because it experience high flow accumulation and the velocity of the water flow. Another factor is factor S. Factor S refers to the degree of the slope factor or the steep fields. Soil erosion occur more rapidly with the slope steepness than it does with the slope length. Steeper fill area can cause water to run off at a rapid rate and cause the velocity of the water flow down to the slope and increasing the soil loss. In the southwestern has high value of the factor S with 200.25% that cause soil erosion to happen in this area is very high.
Next is factor C, all the lands that consist of agriculture and the forestry sectors had 0.5 of factor C, which had a large area of plant cover, while the other areas had a range of 0.5 until 1 of factor C. The occurrence of very high year average soil loss at some of the agriculture and the forestry sectors, which located at the upper part of Western, might be affected by the vegetation management. Moreover, the development of residential areas at several schools and institutes near to the area which very high year average soil loss occurred can be one of the factors that can contribute to the problem. Next is factor P. Soil erosion at UITM was not highly influenced by conservation acts done by local. The value of P factor decreases by adopting the supporting conservation practice as they reduce runoff volume and velocity and encourage the deposition of sediment on the hill slope surface.
As a conclusion, the average of soil erosion at UITM catchment has been analyzed by using the Russell model. There are 2% of the area at UITM have a very high year average of soil loss which occur at lands of the agriculture and forestry sectors, residential area and commercial area. Meanwhile, there are 36% of the area at UITM experience a very low year average of soil which occur at the agriculture and forestry sectors. The factor K, L, C, and S also plays a main role in soil erosions, but the factors of P and R did not highly influence the soil loss at UITM catchment area.
This is our own references. That's all from us. Thank you for watching and have a good day.